and we know that the sun is moving on the sky. So this all makes sense. But suddenly we are in the world of the very, very small, where we just have no intuition for that. And they were just able to find the right theory for that, because they somehow developed to get an intuition for something which is really completely out beyond our reality. This world of the very, very small is behaving completely different, like in our world. I mean, we all know where we are. We all hopefully know where we are. In the world of the small, you can only give a certain probability where something is. So that this electron might, if you have an electron in the shell, you don't know exactly where it is. You just have a certain probability where you can find it. So you know if you look for it, it's most likely here, not here. But it could be also there. And it's all. And the other thing is, we are used to measure everything with very high precision. And the world of quantum theory tells us that we are not able to do that. If we know the position of a particle exactly, then we have hardly any idea about its momentum. If we know the momentum of the particle, we have hardly any idea about its position. So this is, and this makes all no sense from our world. So therefore Niels Bohr was very disappointed when he was invited to talk to some philosophers about quantum theory, and they were all really amazed by what he had to tell them. And he came back to Copenhagen, and one of the persons who worked for him said, "Oh, how was your talk to that philosophical society?" Disappointing. Why? They had no questions. They did not approach me and tell me, "That's crazy. That makes no sense." And one of the persons who criticized quantum theory most was Albert Einstein. So Einstein, who did at the beginning this revolution, he was one of the persons who opposed that revolution and said, "Oh, it makes no sense for that and that reason." And he was one of the remarkable. He helped a lot finding problems in the theory. He helped a lot with the development, but not because he contributed in a constructive way. He really tried to more contribute in a destructive way and identified, but very good problems, of course. I mean, Einstein was also, without any question, a genius like Niels Bohr.
So for this audience, one of the...
Can I ask a question?
Sure.
So it was synchronistic that you talked about philosophy, because I'm going to throw a curveball and switch over to ontology and ask you an ontological question. When you talk about models and measurements and all of these different types of techniques and tools used in science, physics, the weak point in any of those systems is the human mind, right? It's the human mind, and the reality constructs that its neurological systems create in order for it to interpret reality. The human mind does not. We don't see what our reality is. Just a construct, and it's just something that our senses interpret. It's not. No one knows what's there. We only see the explicate reality, we don't see the implicate reality. And that's David Bohm. And given that there's always this uncertainty, I'm not talking about the uncertainty principle, I'm talking about the uncertainty created by the human mind. How is it that you're able to use such positive propositions, or prepositions, my grammar skills aren't that good, when you're talking about this, you often say the model shows that this is this, or our measurements tell us that this is how this is working, when in fact we don't know for sure what we're seeing or what we're measuring because of that, because of us, because of our own imperfections and our own constructs.
Yeah. Oh.
It's the only way that it's possible for us to do that is by having a model that can be independently tested by unrelated groups of scientists and people, and when, because yes, you're right, we're all biased by a point of view, we're all biased by a certain, you know, if we all belong to a certain group and we're all talking about the same things, our minds are gonna start going along that particular flow. So the thought here is to have a model that can be independently tested by other groups that don't have the same bias. We're all limited by biology, that's true. So the closest that we can get is to say that this particular model, which has been independently tested by X number of groups that have no relationship to each other, proves this according to our physical, biological universe that we're living in.
And I understand all that, and you're absolutely right. My question isn't about bias, it's about the human ability to draw an accurate picture of reality, and the fact that they can't draw an actual, and a 100% accurate picture of reality, does that not provide proof of mystery with a capital M?
So, yeah, let me address your question. I think this is a very old question. I mean, the first time I heard about that was Plato and the famous cave where you are in a world where you think all your reality are the shadows, and this is also very popular now in culture, thanks to movies like Matrix, for instance, which also gives a similar approach. My personal answer to that is you have no choice. So if you start wondering about that, and if you start being skeptical all the time, you would never get something done. So as soon as you would start thinking about that and would question everything, there would be no development. There would be no progress. And now I would like just to follow up what you said, and where I completely agree to that. We of course don't create a world. Science is not in a world where we congratulate each other all the time. Science is a world where we try to find faults in the work of everyone else, where we are skeptical on the work of somebody else, and when persons say, hey, wait, you published that, and I did this in my lab and I could not get it done. I don't believe what you have done. And then you start talking to the person and say, wait, have you also taken that into account? Oh, okay, you would do it, and then you put that into account and realize, no, it doesn't work, we still don't believe what you did. Wait, I think you have done this part wrong, and suddenly you realize, oh, I can reproduce that. Or the other guy said, oh, we have done something wrong, and we need to we were wrong in what we are doing. So by this constant questioning each other, I'm convinced that we are able to, and we have already left the boundaries of our own observation, because thanks to detectors, we are not anymore limited to what our eye and what our senses are saying us. By continuously asking us those questions, are these things right, or is there perhaps in contradiction with something? I'm pretty sure that we by now would have identified, or perhaps in 100 years we will find out, wait, we only see the shadows in a cave, and now we somehow need to break out of this cave and see what is really happening. So the hope of our method, of our approach, is that we either have already left those boundaries, or we at least come to them and will break through those boundaries, and to really find what is the deep meaning of nature.
Could I respond?
Yeah, please.
I'm not denigrating the usefulness of science or mathematics or whatever intellectual discipline you that falls into that category of empirical knowledge. I'm not denigrating that, their usefulness or people who work on it or anything like that. From an ontological perspective, though, when addressing questions of being and what reality is and things like that, I don't think that you do approach the entrance to the cave. I think you might get closer, but I don't think you break through, because even when you're using computer sensors or the collider in CERN or whatever tool or technique you care to do, the weak link is still in the system, which is the human mind and perception. That's all I want to say.
Oh, and of course I agree with you about that. And then I would phrase it differently. I would just still base it in my lingo. I think we will never be able to fully understand nature. We will only develop better theories which more accurately can describe nature. And this is all what we're doing. And so I would phrase it in my scientific words, and this is perhaps what you mentioned, with that we come closer and closer to leaving the cave, where the cave is the understanding about nature, of course. I think there's no question about that. And the funny thing is that that nature, of course, has always been there. I mean, if you whatever weird thing you might find in math at a certain moment, in another moment you realize that it's very important to find a certain theory. So mathematicians at a certain moment had a new number system with imaginary units. So we have a real part and an imaginary part. And they developed a mathematical theory for that. Nobody thought that it would be in any aspect relevant to describe nature. And now we are back to waves, particles, and quantum theory. Erwin Schrödinger did not like this approach of Niels Bohr to describe the atomic spectrum. What he wanted to do is he wanted to find a wave theory for that, because this is how his thinking was. And he could not, until he finally put an imaginary unit in front of his formulas, and everything worked beautifully. And then he looked into all that math in order to define that. So this is always these amazing moments in science that you develop something, suddenly you put something in where you thought, okay, no, this cannot be real, and or in that part it's imaginary, but suddenly it makes right, and it describes exactly how nature works. And I think this is a very, very interesting aspect about this interplay of math and physics. Yeah.
Thank you.
And so what he just described was a good example. Although Schrödinger wouldn't say he was a chaos magician, he was, of course, a chaos magician, where he's following the principle that if you're getting results, it's okay. Anything you can use to get results is justifiable as long as it's within your ethical system, and the imaginary number comes in and pow, it explains something. Therefore, it's useful, regardless if it's an imaginary number or whatever. And that's kind of that would be a nexus point of magic and science. The other thing I wanted to say about Niels Bohr is the huge thing that Markus was really describing that's important to this community sitting in the room is concepts about the macrocosm and the microcosm. The scientists recognize the beauty of that, and they're really looking at nature in kind of a different way when this atomic system kind of reflects the celestial system. And then even some of the scientists of the day, I believe Max Born was the one that said, we've been poo-pooing things like astrology for a long, long time now, but what Niels Bohr has done with this, it shows that maybe there is some influence of the celestial system on the microcosmic system, or what it really kind of did a mindfuck on the people there, the scientists. It was a real big breakthrough what Bohr was doing, and then it took great people, some fine tuning of what Bohr did to make sense of some of the things, and Pauli was one of the people, and other people that you've mentioned were part of that process, but just really kind of breakthrough kinds of ideas. And I think the one thing we haven't done at the book on Pauli and Jung, we haven't talked much about Jung and brought any of that in. The book kind of alternates chapters between Pauli and Jung. So maybe the segue into that would be Ernst Mach, I think. For me, that's the segue. Okay, we're sitting in this room. Do we believe in synchronicity? Do we believe everything's just a coincidence? Pauli dying in room 137. What does all this stuff mean? Well, to me, as I would read this book, and I'm looking at the people that were connected to Pauli and the people that he met in his lifetime, it's awfully coincidental. It makes for you couldn't write a bad novel with all that. You wouldn't believe it. You would not believe these things. So for me, the Ernst Mach connection is really kind of interesting, because Ernst Mach was Pauli's godfather. And Ernst Mach was a philosopher and a physicist who promoted a thing called positivism that greatly influenced Freud. And Jung was the opposite of that. He was very polarized with the positive kinds of views. And here comes Pauli into this as a godson, and all these weird interconnections, and you want to address any of that?
Well, I'm not an expert on that. I think as you just read this book, you might know what I mean. To me, Ernst Mach, the importance is because he helped with special relativity, and the main breakthrough is that there is no absolute space. All systems are relative to each other, which was a question already addressed by Kant and then brought up by persons like Mach and Minkowski and Lorentz and then Einstein, who put everything together. But the relationship between Mach and Freud,
and you don't consider like you could talk about positivism much, like what it is or anything? Okay, it's really just the strong viewpoint that everything has to be measurable. If it's not measurable, you could say loosely scientific, then it's not real. And it was just a very strict adherence to that. And Freud brought that into psychoanalysis pretty heavily, and Jung was appalled. He believes there are things that are beyond, that are not easily measurable, but they're still valid. Again, a chaos magic approach. He was using ideas that we don't have a scientific basis for yet, and to us in this room, it would be magic.
I think this is where we're going into Jung's feeling that there were meanings to things that scientists don't generally put meanings to. I think Freud and Jung's great contribution was that they saw meanings in dreams, where before people just thought they were pictures when they slept. And I think that as we develop more a connection between magic, and I'm using like my quote fingers here, and science, is that meaning becomes more relevant as we expand purpose. And I think that's where science could be very helpful. I guess there's supposed to be a question in there. I didn't
hear the question either.
But what do you think? Do you think at what point can science allow for more relevant meaning to basic scientific exploration?
What do you mean by meaning?
Well, like for example, now we have things like numerology, right? Numerology says that there is a meaning to the number 1 that is supposed to affect our lives. It may not be so. I mean, it would be very helpful, for example, if we could walk into a New Age bookstore and see what is and is not real. I think that's what started driving my purpose, is that it drove me crazy, because I know there's something to mysticism. I know there are questions I want to ask, because there is great meaning in things that right now science doesn't particularly, and I blame a lot of it on this positivism and the Vienna Circle and, you know, this huge push that in academics that said you cannot bring up, you know, you can't bring up certain words, you can't bring in certain emotions, you can't do things because they aren't relevant, which set everything back like just decades.
It's not relevant, but it's not measurable.
Yeah,
And that's
right.
the problem.
Yeah. I mean,
That's-
The
That's
reason
it.
it's
So that's the
measured,
thing, if you cannot translate it into numbers or measure it, then it's.
my point, and that's what Jung said, he said that man is bigger than science, like there are things that, so how do we start pushing into that area where we're bringing a structured language to something that seems so amorphous right now?
yeah, I will address this, but there's also a comment.
Well, you mentioned, you know, the number 1.137, how it's the relationship between gravity and all the other forces, right? Well, if that's and it's that special relationship that makes us possible in this physical world right now. But you have in the universe, you have all these other forces, such as the moon, that has a very strong gravitational effect on the planet. And that would skew the number at certain times to 1.1368. Yeah, I mean, you know, just below or slightly above, where it would skew that number just enough to create subtle changes in our environment, that it's just our mind and the way our mind is wired that perceives it.
It doesn't skew the number.
No, this number is only with respect to the electromagnetic interaction, and
But gravity is a strong.
gravity is so there's without a question that there's gravity. There's without a question that the moon has an influence. That's the reason why the water level moves depending on.
But